Chapter 7, Section 2 is about scientific notation. This is a two-part lesson that by the end we want you to be able to change between scientific and standard notation and represent real-world situations using that scientific notation. All right, scientific notation. A number is written like this. Okay, the rules are that our first number right here has to be a number in between 1 and 10. It has to be at least 1 but less than 10. And then your exponent tells you the number of times that you need to move your decimal to get back to your original number. Okay, to the right means plus, positive, and to the left is negative. All right, we have to be able to tell, we're going to look for those two rules to figure out if these numbers are or are not written in scientific notation. Okay, if you notice, this first one is 0.23. Remember that the rule is that this first number has to be between 1 and 0, and since that's less than 1, that means that this one is not in scientific notation. The second one has a number between 1 and 10 and a 10 to the power. So that one is a yes. And letter C, this number fits our criteria, but right here it's not a 10, so this is not in scientific notation. All right, we're going to look at these next three, the A, B, and C that you should have in your notes. If I look at the first one, because this is not in scientific note, or because this is not a number between 1 and 10, it is not in scientific notation. Okay, this is a number between 1 and 10, and this is a power of 10, so this one is in scientific notation. And the third one, this is a number that is not between 1 and 10, and this also is not a power of 10, so this doesn't meet either of the criteria, so those are not written in scientific notation. Down here, these three that I've added should not be in your notes, but we can try them as well. This first one has a number between 1 and 10, and has a power of 10, so this one is. This is too big, so this one is not. And this is also between 1 and 10 with a power of 10, so this is in scientific notation. Okay, if you're ever not sure, come back to these two rules right here to check for scientific notation. Okay, when you are writing a number in scientific notation, we need to make sure that I have those two rules, okay? So here they're giving us this really big number. We need to change it so that I have a number that is written in scientific notation, meaning I have to figure out where I'm going to put my decimal place to make this first number be between 1 and 10. Okay, well, if I put my decimal anywhere besides after the 1, it will be either too big or too small. You have to write down all numbers that aren't zeros. Okay, if it's just a bunch of zeros, I don't need to write those. So we're going to write the 1.43. Oops, sorry. Let's move those over here. 1.43 times 10, and then our exponent tells us how many times we have to move our decimal place. Okay, and if I'm counting, I'm going to have to move my decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Okay, now sometimes you're going to need a -9. If you start with a large number, like this number that we started with, that means I'm actually having to move my decimal place to the left to get it into scientific notation, so I'm going to have a positive exponent. Letter B here shows me the opposite. This time, I have a very, very small number, and I have to move my decimal place to the right to make it a number between 1 and 10, which means my exponent is going to be a negative number. So this one becomes 1 times 10, and then we count how many places we moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places, so it becomes a -10. Hey, remember this. If it's a very small number and we're changing it to a larger number, it's going to have a negative exponent. If it's a large number and we're making it smaller, it will have a positive exponent. Okay, we're going to actually try it right here. We're going to take these numbers and put them into scientific notation. Okay, so I have to figure out 678,000 is way bigger than being between 1 and 10. So where can I put my decimal to make it a number between 1 and 10? And that would be right after the 6. So when I fill out I call it dash dot dash times 10 to the dash, that means I'm going to put my 6.78 right here. Now, this is a really big number that I'm making a small number, so it's going to be a positive exponent. And I would have to move my decimal place 1, 2, 3, 4, 5 places. So in scientific notation, 678,000 is 6.78 times 10 to the 5th. Okay, letter B is a very small number that I'm going to be making bigger to fit scientific notation, so I will have a negative exponent. Okay, I have to put my decimal between the 3 and the 2. So I will have 3.2 times 10. And my decimal would have to be moved 1, 2, 3, 4, 5 places. So it will be -5 since I'm making this one bigger than it started. Letter D we're also making bigger than it started, so let's go to that one and try that out. To make this a number between 1 and 10, I'd have to put my decimal after the 7. So I will have 7 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Okay, and then letter C, back to being a big number that I'm making smaller. To get between 1 and 10, I have to put my decimal after the 5. So I have 5.14 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. Okay, sometimes they're going to give you a number that is not in, or that's already in scientific notation, and we need to turn it back into what they call standard notation. Okay, standard notation is just what the regular number looks like without the power of 10 at the end. So when they give us 5.5 times 10 to the 6th, this positive exponent moves my decimal to the right. Okay, so 5.5 times 10 to the 6th means I move my decimal 6 places to the right to get 5,500,000. Opposite goes for a negative exponent. Negative exponents move our decimals to the left. Okay, so this one starts as a 3.1, and then I have to move my decimal left 3 places. 1, 2, 3. And I fill in any extra spaces with zeros. So 0.0031 is how we would write this 3.1 times 10 to the negative 3rd in standard notation. Okay, we're going to practice that with these two. Letter A, because this is a positive number, we're moving to our decimal to the right 6 places. So 2.8, move our decimal 1, 2, 3, 4, 5, 6 places. Fill all of these in with zeros. And my number would be 2,800,000. Letter B has a negative exponent, so I'm going to move that decimal to the left. The number 2 decimal is behind it, so I'm going to go back 1, 2, 3 places, fill in the gaps with zeros, and I have 0.2 or 0.002. All right, this one we're going to practice tomorrow, so that's the end of part 1. You can check out part 2 once you've finished the homework for part 1.